Hello, in this video we'll move into section 12 where we will discuss solving polynomial equations by factoring. Now this is a very important thing to note, especially for those of you in an online class. Following the directions, sticking with the class, you have to make sure you're learning this technique. For some people, they'll see some problems and they'll jump to quadratic formula. We will eventually discuss the quadratic formula, but it's not here. So that's the first point. The second point is that this technique, as you can see, is entirely based around factoring. So that's why in the previous video, sections 9, 10, and 11, we really harped on trying to make sure you're good at factoring, because all of these problems, and not just this section, but a couple of the sections going forward, they really rely on you knowing how to factor. Now, we will see the factoring is not too bad, but you still have to know all of your basics of factoring. Greatest common factor applies to everything. We always look for that first. And then by our different standards of a 4-term polynomial, well, we're thinking about grouping. A 3-term polynomial, a trinomial, we're thinking about the grouping number. If we're looking at binomials, we're thinking about our special forms. So, that's where we start. But here, how does all that apply to solving an equation? And this is where our book introduces what they call the zero product property. The zero product property. And they have a nice little sentence to explain it. If the product of two numbers is 0, then one of the numbers must be equal to 0. And if we translate that from English into an actual formula, that tells us that if we have A times B equals 0, then either A is 0 or B is 0. And that's something we could certainly understand. Just think about it. How do you multiply something and get 0? Well, if I've got a 2, 2 times 0 gets me to 0, and that's it. And notice that's special. That's not a common thing. If I say, well, A times B equals 8, does that mean A equals 8 or B equals 8? I mean, that's a possibility. It could be 1 times 8 equals 8, but it also could be 2 times 4 equals 8. So the important thing to note here is that this really relies on the equation being set equal to 0. So that's the key. If my equation is set equal to 0, and then I could break this apart into factors, things that multiply together, then I will take each of those factors one at a time and set them equal to 0. And our book does it for just these 2 factors, but if it was more, if I had this expression factored into 3 pieces, well then I would set all 3 pieces individually equal to 0. This is the key here, everyone. We are taking a complicated equation with a higher degree polynomial, setting it equal to 0, breaking it into its base factors so we could solve this smaller, more basic, easier equation. That's the idea. So now that we have the idea, the rest of this video in part 1, we are going to get a lot of practice going through and doing this and seeing some of the little nitty-gritty points to make sure you're aware of. In part 2 in this section, we will get into word problems. But again, we'll get into that in part 2. So let's start off. Solve the equation. We are looking to solve the equation, and problem number 1 is 3x squared minus 15x equals to 0. Okay, what are we doing here? Well, this has the form that we're looking for. It is already set equal to 0, but over here, this is the first little misunderstanding. People just see 2 pieces here and set each piece equal to 0. So in this problem, they just go, okay, not fully understanding what is being said here, they just start doing something like 3x squared equals 0, minus 15x equal to 0. But you got to understand, that's not what we're seeing here. This needs to be A times B, not A minus B. So that's not it. So what we're doing here, that's where we come over here. I look at the other side, the side that's not 0. I want to make it into an A times B. I will do that by factoring. How am I going to factor this one? Well, I look across, I see common terms. 3 and 15 share a common 3. X squared and x share a common x. So a 3x is coming out. What's left? Same thing I've always said, everybody. When you're doing your GCF, your greatest common factor, some people are comfortable just pulling that out and knowing what's left behind, thinking about just literally what is left. Other people on the side, they're dividing. The 3's cancel. X squared divided by x is x. So there's an x left right here. And then the minus sign is still there. 15x divided by 3x. Well, 15 divided by 3 gives me 5. X's cancel, so all that's left is the 5. That now has the perfect form. It had the 0 in the first place, but that's the a times b that we're talking about here. Something times something else equals 0. Now I will move to that next line. I will take each of those somethings, set them equal to 0 individually. So I'll get 3x equals to 0, and then I'll get x minus 5 equals 0. We started off with a harder equation. Why is this equation harder than the stuff we were doing in sections 1, 2, and 3? It's all about the exponent. If we only had an x to the first power, we'd go back to those original ideas of isolating the variable. Variables to one side, numbers to the other, and that's that. But this higher power of x is what forced me to do this. But now each of these are back to those more basic equations. I'm going to start over here, finish solving for x. Well, I want the x, the minus 5 is attached by subtraction. So I'll add the 5 to both sides. One solution would be x equals 5. Now come over here and just be careful. People see this, and especially after seeing this one, they go, okay, he added 5 to both sides to finish solving x. Over here, they go, I'll subtract 3 from both sides and get x equals minus 3. But note the difference in the connections, folks. This is addition subtraction, hence we're using the opposite here. This is multiplication. I'm dividing both sides by 3 to finish solving this one. And on the left side, the 3's cancel. I'm left with the x. The right side, 0 divided by 3. I know it looks funny, but 3 times what gives you 0? 0. We got two solutions. X is 0, x is 5. And this is kind of like, don't want to compare it too strongly, but when we solved absolute value equations, we had multiple solutions. I'm always fine if you just list them individually like I did here. If you want to put them together, just remember your set theory notation. It's curly brackets. Don't do any parentheses. People will misunderstand that as the interval 0 to 5 or an xy pair 0, 5, x is 0, y is 5. That's not what we're seeing here. These are two separate solutions. That's the way to do it if you want to use the set notation. But again, folks, I'm perfectly happy just following your work and just seeing multiple answers at the end. That's a-okay with me. Let's keep going. Let's get more practice. It's a nice idea, and now you see exactly what I'm talking about. You need to be able to factor. It's not the only thing we have to do here, and the problem doesn't say anything about factoring in the directions, but that's understanding the concept. So now we move on to number 2. Number 2, let's look at 8x squared minus 10x minus 3 equals 0. For number 2, we are already in our good starting point like we were number 1. One side is already equal to 0. To be clear, everybody, this makes it seem like it always has to be the right side equal to 0. Let me come back to number 2. This is the exact same thing. So actually, let's even pretend that's where we started. The 0 is on the left side, but the point is one side is already set equal to 0. That's what we want. We need to factor the other side. But now factoring this expression, well, I see a 3-term polynomial. I still think about GCF first. 8 and 10, well, they've got a common 2, but 3 doesn't have it. X's, still got X's, no GCF. So where do I go from here? I see a nice trinomial. The x squared, the x, the no x, that's my nice trinomial setup. I will look at the grouping number. 8 times -3 gives me -24. What multiplies to 24 and subtracts to 10? Well, 1 and 24 would subtract to 23, but 2 and 12 would subtract to 10. I need it to be a -10, so a +2 and a -12. The 8x squared stays. I'm breaking the middle term into these two. I'll get a plus 2x minus 12x minus 3. And the point of the grouping number is so that I now have a 4-term polynomial, and I can group. My first group, 8 and 2 share a common 2, x squared and x share a common x. Just like I was saying up here, everybody, if you need to do these divisions on the side, there's no shame. Make sure it's right. But if you're comfortable, 2 times what gives you 8? Well, 2 times 4. X times what gives you x squared? X times x gives you x squared. 2x came out, nothing left, but there's got to be something there. 1 is the placeholder. Again, I could always redistribute to see that I'm correct. Over on this side, 12 and 3 share a common 3, but as we've seen, we're going to take the negative out to go with that, so that'll give me a positive 4x here, and I'll be left with a positive 1 here. I know I'm on the right track. Good habits, still good to keep the other side of the equation, everybody. So I still have my 0 on the left side, but big picture, I see this matches. So now, 1 term, 2 terms, they've got a matching factor. That matching factor comes to the front. That came out, the 2x left behind. Over here, the 4x plus 1 came out, the minus 3 left behind. And now, just like in number 1, now that I've finished factoring, each factor set equal to 0. So this time, 4x plus 1 equals 0, 2x minus 3 equals 0, one at a time. I'm going to start over here, subtract 1 from both sides. I'm getting a little low on space here, folks. I'll finish right here. This cancels. I've got a 4x equals minus 1. Finish solving for x. Divide both sides by 4. My first answer is -1/4. Over here, very similar. Trying to get to x, got to move the 3. I'll do a plus 3 on both sides. Cancels here. Come right up here. The 2x left on the left side. Positive 3 on the right. Divide both sides by 2. X equals 3/2. As we've always seen, fractions, decimals, you'd rather make that a decimal, -0.25. Maybe this one a mixed number, 1 1/2, or the decimal, 1.5. I'm A-okay with all that, folks, just like we've seen before. When we had slope, we specifically wanted to see a fraction, but for these problems, just solving the equation, fractions, decimals, no problem one way or another. Last thing to note before we move to the next one, notice, again, I had my 0 on the left side here. Some people might say, well, professor, shouldn't it go 0 equals 4x plus 1? Sure. Again, that's where it's so easy, folks. You could always flip it. In an equation, A equals B is the same as B equals A. So if you're ever bothered like you have this and you don't like the 0 on the left, put it back on the right. That was the big picture of this technique. We needed one side to equal 0. A lot of people like the right side equal to 0, but if it's on the left, just put it on the right. No penalty for that, nothing extra to be done. All right, let's keep going. several more we want to do. Make sure we're getting plenty of experience. Number 3, we're still solving for x. Number 3, we're looking at 2x squared plus 8x minus 2 equals x squared minus 2x minus 18. We're finally looking at our first mess. The previous 2 problems, again, higher level equations, multiple variables of x, multiple powers of x, but they at least both started off with they were equal to 0. When people misunderstand the zero product property, and by the way, folks, you don't have to remember that name, but just the idea that we're using here, people miss that. They just start jumping in and start factoring. They see a nice trinomial here. They're doing a grouping number. They're doing a nice trinomial here. They're running over to the grouping number. Funny thing is, in both of these, you'll notice you're not getting anything that works. And that's kind of a nice indicator something's wrong. What's wrong here? It's not equal to 0. Factoring for just factoring doesn't help. The whole point is that it needs to be equal to 0, so then your factoring is actually productive. It's actually leading us closer to the solution because then we could use those factors going forward. But again, if it doesn't equal 0, so what? A bunch of factoring, if I know, just quickly point out some numbers, well, 30 equals 30. Well, knowing 30 is 5 times 6 while also being 2 times 15, so what? This factorization tells me nothing about this factorization. There's just no good connection here. So again, big pursed idea needs to be equal to 0. Let's start moving some terms. 2 things here. Most people, they like 0 on the right side. So they want to make this side 0 and put their stuff on the left. But kind of like what we saw in basic equations, there are some minor preferences people have. What you'll notice when we factor, we like our leading term to be positive. So if you move this term to this side, you do a minus 2x squared on both sides, you'd end up with a minus over here in front of your x squared. That's not as desirable, and that often leads to an extra step. So how can we avoid that? Well, this is where the problem matches. People like 0 on the right side. People like a positive leading coefficient. Well, if we move this stuff to here, that'll do it for us. How do we move it? Well, one piece at a time. I got to move the x squared. It's a positive x squared. So I'll subtract x squared from both sides. Some people will do some work and come and form a new line. I'm just going to keep going because I'm going to notice, well, this has to go as well. A minus 2x will cancel with a positive 2x. And whatever I do to one side, I do on the other. Notice I'm intentionally lining up like terms. This is what cancels, but when I do this action on the other side, this is what will combine. And same on the last one, the minus 18. We'll get rid of that with a positive 18. Whatever I do to one side, I do to the other. Right side, x squared minus x squared cancels. X squareds are gone. Minus 2x plus 2x cancels. X terms are gone. Minus 18 plus 18 cancels. What's left here? Well, when we factor, there's got to be a placeholder, and that's the 1. But in this case, it's all there's a 0, there's a 0, there's a 0. Everything left is just 0. And that's what we wanted. I wanted the 0 on one side, but now it's not just the original 2x squared plus 8x minus 2 on the left side. I got to work this stuff in. 2x squared minus x squared is 1x squared, or x squared. 8x plus 2x is plus 10x. Minus 2 plus 18 is plus 16. Now we're on track. Now we are ready to factor. Now I've got it all set equal to 0. For some of you, this is the nicer trinomial with the leading coefficient of 1, but as we've seen, I'm still going to do it with the grouping number. I took a quick second, saw no GCF. Grouping number, 1 times 16 is 16. specifically positive 16. What multiplies to 16 and adds to 10? Well, 1 and 16, nope, that adds to 17. 2 and 8, there it is. Positive 2 and positive 8 will add to positive 10. So x squared plus 2x plus 8x plus 16. Breaking that middle term into these two. Grouping. And as you see, folks, this is where I've said if you're good at factoring, these problems just flow very well. If you are not good at factoring, this is torture, one step to the next. Just getting it equal to 0, knowing where to go from here. Even just here, now you've got the grouping number, but breaking this up, GCF, x out, x plus 2 left behind. Over here, 8 out, x plus 2 left behind. The nicer thing in this section, I don't want to say the factoring is easy here, but the factoring doesn't tend to be quite as complicated as it is sometimes when it's just factoring. When they just want us to factor, they can throw some hard ones at us, but they tend to be a little more friendly. So again, you kind of have a good sense that if this matches this, you're on the right track. I see it, I keep going. If it doesn't match, did I make a mistake up here? Did I make a mistake back here? Again, it's not easy to find a mistake in a math class, but you can kind of get in a groove and see when problems are working like the other ones have in class and when they are not working. This one is, so let's keep going. X plus 2 comes out. X plus 8 left behind. Each one equal to 0. And now for both of these, not too bad. Solve for x here, just an easy minus 2. And my first answer is negative 2. Over here, subtract an 8 from both sides. My second answer is negative 8. All right, let's keep going. Still getting good practice. Seeing how this one not being set equal to 0 is an important feature to note. And this comes up again in number 4. So we get into problem number 4. We're looking at 8x squared equals 72. Doesn't look as bad as this one, but it has the same issue. It's not equal to 0. So what do? I'll make it equal to 0. I'll once again stick with the right side. This side is already positive. I'll do a minus 72 on both sides. On the right side, it cancels. There's my 0. On the left side, I'm trying to not line these up because they're not like terms. It's an 8x squared minus 72. That's the best I can do. Now I have it equal to 0. Now I'm factoring. Well, I see a 2-term polynomial. I don't see any nice special form, but I didn't think about GCF. First things first, GCF, 8 comes out. 8 comes out of 72. First 8 comes out of the 8x squared, left with x squared. 8 comes out of a 72, and you're left with 9. So good factorization, but now we need to remember this is the one little new addition in number 4. It almost looked like an easier version than number 3, but the new thing to remember, factoring is not always just one step. The previous ones, things factored nice. We had nice basic equations. But here, that's still a little bigger because it still has the squared. And that's where we need to recognize that is the difference of squares. The 8 is still hanging out. This is an a squared minus b squared, where a would be x, b would be 3. So this will factor x minus 3 times x plus 3. And now I have 3 factors. And this is what we were saying in the beginning. Again, the first couple, we finished factoring with 2 factors. So we had 2 equations. This time we have 3 factors. We will have 3 equations we need to solve. And I want to start with these two. These are the easy ones, right? Here, add 3 on both sides. X equals 3. Over here, subtract 3 on both sides. X left on the left. 0 minus 3 is minus 3. I've got 2 solutions. This one, very easy to make a mistake. It's very easy to confuse this with something that we saw back in problem number 1. Here we had 3x equal to 0. We divided both sides by 3 and got an answer, x equals 0. Here, there's no x. So what do we have? We have 8 equals 0. Well, that's nonsense. That's just a no solution equation. So again, it's not that we had to, we could ignore this. We had to pull the 8 out in the first place to make this work. But in the end, without having a variable, it doesn't offer any extra solution. My solutions are still just right here. These two, x equals 3 and x equals negative 3. Let's keep this rolling. We still want to do a few more. We're getting really good practice, but just a few more and we'll wrap this up. Number 5, let's look at 5x squared equals 17x minus 6. Again, doesn't look that intimidating, but still has a little bit of an annoyance. Not equal to 0, let's make it equal to 0. I'm going to stick with the right side equal to 0, and one more time, I'm also noticing I've got the positive in front of the x squared here. I'd like to leave that alone. So to move these, I'll do a minus 17x on both sides, and this I'll do a plus 6 on both sides. Right side, it all cancels. This cancels, this cancels. There's my 0. My left side, again, I'm trying to make sure I'm not lining anything up because none of these are like terms. I don't add these two and get an 11x squared. I don't combine these two and get a negative 12x. They're not like terms. So just what do I have? Well, let's at least be nice to ourselves and put them in order. 5x squared first, minus 17x second, plus 6 third. And now we are back on track one more time. No GCF, nice trinomial, going to my grouping number. 5 times positive 6 is positive 30, multiplies to 30 and adds to 17. Well, 1 and 30 add to 31, 2 and 15 add to 17. But it needs to add to negative 17, so both of these are negative. 5x squared minus 2x minus 15x plus 6 when I force those into the middle. Again, we're not going to keep redoing these problems multiple times, but for some people, maybe they'd rather have the minus 15x first, the minus 2x second. We've seen that in the exact moment it looks a little different, but in the end, it'll yield the exact same result, but I'll leave it as is. First group, just an x. That's all. 5x minus 2 left behind. Second group, reminder, if you're not seeing the good common factor, use this. You got to be left with a 5x minus 2. How can a 15 become a 5? How can a 6 become a 2? You take a 3 out of them. More specifically, you take a negative 3 out of them. Again, leading term negative, take that negative out with it. That leaves me the positive 5x here. Again, no shame doing this on the side. Minus 15x divided by minus 3. That minus over a minus is why I'm getting a positive. 15 over 3 gives me the 5. The x is still there. 6 over negative 3, I get a negative 2. There's the matching 5x minus 2. That comes out. The x minus 3 left behind. 2 factors, each set equal to 0. 2 equations left to solve. Right here, add the 2 on both sides. 5x equals 2. Finish solving for x by dividing by 5. cancels here, x equals 2/5, first solution. Second solution, simple add 3 to both sides, and that's it. X equals 3. Go back to the very beginning, everybody. You could do this for every single problem. How do you know you're correct? How do you check your work? The same way we've checked equation solutions from the beginning. Here, take it, plug it back in the original. 3 times 0 squared minus 15 times 0. 0 squared is 0, times 3 is 0, 15 times 0 is 0, 0 minus 0 equals 0. Check. Do the 5, a little more complicated, but it would work. 5 squared is 25, 3 times 25 is 75. Minus 15 times 5 is minus 75, 75 minus 75 is 0. You still check the same way you always used to. Go back to the original. So in something like number 3, don't test here. Go back and test here. If you test here, well, any little mistake made from this part to this part, you would not be able to catch that. But the second thing to note, again, a lot of these we're getting 2 solutions. You can't check them both at the same time. Just like our absolute value, you would be testing them one at a time. All right, now we'll move on to problem number 6. For number 6, we're looking at 2x cubed equals 50x. Doesn't seem that bad. Seems very similar to number 4. Not too much going on, but I need one side equal to 0. I'll make the right side 0. Minus 50x on both sides. I'm drawing my little line down the middle here just to, again, try and separate my left and right. Right side cancels out, gives me the 0. Left side, not like terms. So that's where I could slide this over it, but still have my arrow to make it clear it's on the left side, but these are not like terms. 2x cubed minus 50x. Now I'm ready to factor. I see a GCF here. 2 and 50 share a common 2. X cubed and x share a common x. X squared minus 25 left behind. Can still keep going. Back here, linear factors are done, but something like this, an x squared, still has possibilities. An x squared minus 25, this is another difference of squares. Gotta say it, folks, the book loves difference of squares. So of all the forms, the special forms at least, you really want to make sure you're familiar with that one. A is x, b is 5. That's how this is a squared minus b squared. The 2x comes down, x minus 5 times x plus 5 finishes the factorization. 3 factors this time, each one equal to 0. And unlike the last time we saw 3 factors, this time we will get 3 solutions. The last time we saw 3 factors, one of them was just a number, and that didn't yield anything extra. So we just got answers from these 2. But this time, well, over here, add the 5 on both sides, x equals 5. Subtract the 5 from both sides, x equals negative 5. But here, you do have an x. So make sure you finish solving this one for x. Divide 2 on both sides, x equals 0. Some people notice it's not a perfect rule, but the highest exponent is a good guide on how many solutions you could expect. Highest exponent was 3, we got 3 solutions. Over here, highest exponent was 2, we finished with 2 solutions. It's not perfect, everybody. That actually gives you the most solutions you could have. But there are times you'd have something like this, you only end up with 1 solution. Or maybe you end up with a repeated solution. You get x equals 5 twice. So that's where it's a nice thing that a lot of people notice, but it's not a perfect rule, but it works very, very nicely in this class. And by the way, if you do take pre-calc, they'll explain that rule more about how, again, the upper limit is that exponent, but then again, how things don't always work out so perfectly. All right, last one for part 1. Number 7, let's solve x cubed minus 3x squared minus 4x plus 12 equals to 0. Want to solve this one? Well, the nice thing, after a bunch of problems where we had to start getting one side equal to 0, number 7, we're finally back. The right side is already 0. So I'm just working, I'm thinking about my factoring. GCF, don't see anything across all 4 terms. But it's a 4-term polynomial. I'm thinking about grouping. First group, x squared comes out, x minus 3 left behind. Second group, a 4 comes out, but again, we'll take the negative with it. That's about the 3rd time today we've seen that. The negative has to come out with it so that this will be a perfect match. Minus 4 comes out, leaves you x. Minus 4 comes out, leaves you a minus 3. Sorry, that's a minus 3. Matching x minus 3 comes out in front. X squared minus 4 left behind. This is good, but now one more time, I see another difference of squares. I've got a quadratic left here, a 2nd degree term, and I notice it's got that perfect form, a squared minus b squared. Keep going. A squared is x squared, so a is x. B squared is 4, so b is 2. The x minus 3 comes along. We don't lose it, just like over here, the 2x just kept going. But here, factors a minus b times a plus b. 3 factors, x minus 3 equals 0, x minus 2 equals 0, x plus 2 equals 0. Add the 3 on both sides. First solution is x equals 3. Add the 2 on both sides. Second solution is x equals 2. And last, subtract the 2 from both sides. Last solution, x equals negative 2.